The last time we were talking about the preliminary topics, preliminary in the sense that these are the concepts that we need to understand the concepts that are included in our course. So we actually started with the concept of numbers, our real number system. We talked about the different types or kinds of numbers. We also agreed that in this course, we will be talking about the set of real numbers only. Hahayaan muna natin ang complex numbers. We also discussed the Cartesian coordinate plane. That's where we plot points and then graph functions. And speaking of functions, we defined that one. We also presented the different ways on how we write functions. We emphasized that in a calculus class, we normally use, of course, the graph and the equation. We started with the types of functions, the most basic ones. The algebraic functions, for example, our polynomial functions, yun yung na-discuss natin. So this afternoon, we will continue to discuss the other types of functions. So after the polynomial functions, still algebraic, we have what we call our rational functions. So I hope that we do not forget the concepts that we discussed in the previous lectures, because they are all useful in understanding the present concepts. So the concepts here are intertwined, they are connected. So we will now discuss rational functions. And to do that, I have prepared a GeoGebra file. So I hope you are familiar with GeoGebra. You can actually download that and use if you want. It's really helpful. So in the interface, in our GeoGebra interface, I'm not sure if I have presented this one already in the previous meeting, but this is the interface, the basic interface. At our right, the left side, we can see here the different function. This is where actually input the functions, and then at the right side is the corresponding graph. All right, so it was presented in your module that the definition, ano bang definition ng ating rational function? It's actually just a function composed by or comprised by two polynomial functions, and that function is a ratio of those two polynomial functions. So by notation, the general form is, this is a rational function, p of x over q of x. So what are p of x and q of x? Those are functions, specifically a polynomial function. So parang fraction lang natin na dalawang polynomial function, yun yung ibig sabihin ng rational function natin. Of course, we have to specify that q of x cannot be equal to 0, because again, division by 0 is undefined. We discussed that one also in the previous lecture. So that is basically the form of our rational function. Basta polynomial yung numerator, polynomial din yung denominator, except for 0, that is already considered a rational function. So what you see in the GeoGebra file now, yung naka-click dito, it's a very simple rational function. The numerator is 1. Is 1 a polynomial function? Yes. This is a polynomial function. In fact, all constants are polynomial functions. And then we have a monomial as the denominator, x. So 1 over x is a rational function. The rational, the root word is a ratio. So a ratio of two polynomials. And we can see here the graph of this particular rational function. The red line here, as you can read it here, is actually the asymptotes. What do we mean by asymptotes? These are horizontal or vertical lines from which the graph gets nearer and nearer to, but does not actually touches. So this part of the graph here, it is actually becoming closer to the positive y-axis, but it will never touch exactly at the, or it will never get it here Parang even if we zoom it out, never siya na magta-touch doon sa y-axis natin. Yun yung ibig sabihin ng asymptote. So kahit ilagay pa natin sa pinakataas yan, this function will just approach the y-axis. The y-axis to be specific, but it will never touch. So this one here, this line here serves as an asymptote. In this particular rational function, we have two asymptotes. So the first one is this vertical line, which overlaps exactly the y-axis, because it's not always this case. And then we also have another asymptote that overlaps exactly our x-axis. This is our horizontal asymptote. So for the rational functions, I have already included there. And the asymptotes really will help us in identifying again the range and the domain of the functions. So, gano'n lang naman yung rational function, basta later on, makikita naman natin to, we will investigate other rational functions, not as simple as 1 over x. But anyway, speaking of range and domain of functions, ang sabi natin the last meeting, it's really easy to spot the domain in the range of a particular function, especially when given the graph. Of course, we can also do that, and we should be able to do that even without the graph. So we start identifying the range and the domain of a function given the graph, and then later on, pag medyo masanay tayo, then we must be able to identify the domain and range of the function given the function only and not the graph. So okay, starting with the domain again, the domain is that part of our x-axis that is covered by the graph. More technically kasi, the domain is, di ba, the set of all values of x that can serve as an input. What numbers can we put as the value of x in this particular function, 1 over x? Lahat ba ng real numbers ay pwede nating ipasok dito, i-substitute, kumbaga, dito sa 1 over x? Well, no. Obviously, no. Ano yung exemption? What do you think?
0%.
0. And why is that again?
Magiging undefined.
Yes, magiging undefined. So if we look at the graph, actually, it is covering every number here, mapa-negative man yan, or mapa-positive numbers, lahat naman ay naka-cover ng graph. Pero, the graph will never or does not have a value exactly at x equal to 0. So, when we write the domain, then we have to think of that. Any number can be put or can be substituted as the value of x here dito sa ating function na 1 over x except for 0. So when we write the domain of this particular function 1 over x, so this is the domain. How do we write it then? All x that are element of the set of real numbers except for 0. And if you notice, it's exactly, diba? The horizontal asymptote crosses the vertical, I should say. The vertical asymptote crosses this value at x equal to 0. Now, how about the range? The range is the part of the y-axis covered by the graph. And if we look at the graph, there's a part of the graph na naka-align naman sa negative y-axis, ganun din sa positive y-axis. But there is an exemption. What part of the y-axis ang hindi kasama sa range? Anyone? 0 pa rin. So when we write our range, that is the set of all y's. Gamitin natin yung variable y to indicate that we are pertaining to the values or to the numbers in our y-axis. X naman kapag domain. It could be any real number, element of the set of real numbers except for 0. So that this is the domain in the range of this very basic rational function. Other terms, this one as the mother function of all rational functions. Alright, so let's move on to another example of a rational function. It's 3 over x minus 2, and that's the asymptote. So you see, the vertical asymptote now is not exactly at the y-axis. So the numerator here is again a constant, so that is a polynomial, and the denominator is a linear function, still a polynomial of degree 1, x minus 2. So magkamukha, no? Magkamukha, if you click this one, magkamukha yung kanilang graph, except that it was translated to the right. Medyo na-transfer sa right part ng Cartesian plane yung graph naman ito. So these are the asymptotes. The vertical asymptote passes the x-axis or crosses the x-axis at positive 2, and then the horizontal asymptote passes the y-axis at 0. So what are the range and the domain of this particular rational function? So suppose na nga we cannot see the graph and we are only given the equation. It's a rational function, so what are we actually excluding in the domain? If the denominator is x minus 2, ano yung bawal na maging part ng domain? Positive 2. Because, well, obviously, by intuition naman, alam natin na kapag 2 yan, magiging 0 yung denominator natin because 2 minus 2 is 0. So, that's an exclusion. So we have to exclude it from the set of real numbers. 2 lang ba ang bawal dito?
Sure, 0.
0? 0 minus 2. What's the answer? Minus 2. So 3, negative 3 over 2 is a real number. So walang problema kapag x equal to 0. We are still talking about the domain. So the domain is a set of all x element of the set of real numbers except for positive. Ganon. So kung nagkataon na ang denominator natin sa rational function na ito ay plus x plus 2, ano yung bawal doon?
Negative 2.
Negative.
Negative 2.
So tinitingnan lang natin kung ano yung nakakapag-0 pa din. Bawal yon. We exclude it from the set of real numbers. Yeah. So the range, ang range naman natin, we look at the horizontal asymptote. So normally the asymptotes tell us what is not included in the range. So saan dumaan yung horizontal asymptote?
0.
0 pa rin. So element of R, y cannot be equal to 0. That's it. So hopefully, you will see the pattern here so that without the graph, we can identify the range, the domain. Yes, and the range, of course. Let's have another example. Our function now is, kamukha pa rin siya, x plus 4 over x minus 2. Both linear functions. So polynomial ang nasa taas, x plus 4, polynomial din yung nasa baba. Now, what is the domain of this function?
2, sir.
Ganun pa rin, 2. Ganun pa rin. How about the range?
1, sir.
1. So, how did we know it's 1? Yung horizontal asymptote, no? That is actually 1. Yan. How do we know the range if we cannot see the graph? Actually, we can identify the range by doing an algebraic process. So that's the inverse. So ang gagawin natin dito ay kukunin pa yung inverse ng h of x, tapos yung domain ng inverse na yun yung range ng original na function. But I think in this class, hindi na natin masyado kailangan. So basta we know how to look at the graph and be able to tell the range of that function based from the graph, then that's okay. So palitan lang natin ito ng 1. Right, let's have another what? This is my last example, I think. Yan. The rational function here is x squared minus 9 over x plus 3. Alright? So you tell us now the domain. What is the domain? By merely looking at the denominator, ano dapat yung domain siya?
Negative 3.
Right? So negative 3. Bawal ang negative 3. How about the range?
Negative 6, sir.
How do we know it's negative 6?
Graph, sir.
Okay? So, of course, the domain excludes negative 3. So, at this point, if we trace it at this graph, from the graph, kung sana kasama siya, ang partner niya dapat yung point na ito ay negative 6. However, since this is a rational function and the denominator cannot be equal to 0, then negative 3 is excluded from the domain. So that negative 6 will also be excluded from the range. So, this is actually a line. Bakit line lang yan? Because if you simplify x squared minus 9 over x plus 3, that is actually the same as, if we simplify this one, this is actually the same as x minus 3. So, line lang siya. It's a linear function. However, since the original function is a rational function, we need to exclude nga that value that could make the denominator 0. That's why we put a hole in that particular part of the graph. So this is different, although algebraically the same as x minus 3, the graph is a little bit different from the simplified form. Meron lang siyang hole dito sa negative 3. So again, the range will exclude negative 6. Negative 6. Yeah. So that's all about rational functions. Do you have questions? Questions? Right? Wala siguro. Okay, so what's the next type of function na meron tayo dyan? Ano yung susunod?
Radical function, sir.
Ayan. As you can see here. Diba? So what is a radical function? Nasa binigay din natin sa module yan. The general form of a radical function is anything that looks like this. So g of x is any function na nasa loob lang siya ng radical sign. This is called the radical sign. Whatever g of x is, whatever this is, it's called the radicand. And then the number here is called the index, represented by n. This is that is just our radical function. You can see in our GeoGebra the simplest radical function that we can generate. So the function g of x here is just x, a very simple polynomial. It's a monomial. And the index here is 2. So how do we read this one? This is read as square root of x. Of course, if the index is 2, we do not normally write 2. So we do not have to write if it's 2. If it's 3 or 4 and so on, then we have to specify that. Cube root of x. So ganyan. Cube root of x. Fourth root of x. Fifth root of x, and so on and so forth. Yeah, so balik tayo dun sa pinaka mother function natin. So this is the graph of square root of x. Ngayon, tatanungin natin ulit yung domain at saka range. Domain at saka range. Anyone? Domain, unahin natin kay square root of x as was shown here. Ano yung domain niya? Based from the graph. Does it cover all parts of the x-axis?
Where x is greater than or equal to 0.
X, everything that is greater than or equal to 0. So 0 paakyat, yun yung domain because that's the part of the x-axis covered by the graph. So tama. Lahat ng x, how do we write it? All x that are element of number, however, it has to be greater than or equal to 0. Pwede namang baliktad ito. Pwede nating unahin yung x greater than or equal to 0, x element of R. It means the same. How about the range? Anong range niya? Obviously naman, because we are given the graph.
Greater than or equal to 0.
Yes. Why? Greater than or equal to 0. So, hindi, anong ibig sabihin nun? Walang y value na magiging negative. Lahat ng y value natin dito ay yan, pataas. Yes. Okay. Now, I'm going to change the index. So instead of just square root of x, we'll have now a different radical function. It is cube root of x. So we have cube root of x. Sabihin natin g of x. Sige, f of x. What if our radical function is cube root of x? Ano yung domain? Anyone?
Any real number here?
Yes, all the real numbers as graph. So, pwedeng isulat lang natin dito para shortcut na R. Set of real numbers. How about the range? It's the same. So wala namang ano, no? Ito, syempre hindi natin makikita na covered yung 5 and 4 and 3 kasi that part of the graph is hindi na kayang kunin dito sa interface. So theoretically, if we extend, it will cover everything here. So we write the same. Now, let us move on to 4 as our index. I want you to look at the graph as we move on and then observe some patterns if there are. So this is 4th root of x already. This is 5th root of x. 6th root of x. 7th, 8th, 9th. Yeah. So if we continue, so any pattern that you observe, anything that you observe from what I just shown you?
If the index is even number, the domain in which is greater than or equal to 0. And if adds number, the domain and range is real number.
Okay. So yun lang naman ang gusto nating i-emphasize dito. So that's 5th root of x. Now, what if we change the radicand? Instead of just x, we put some numbers there. For example, plus 1. So this is square root of x plus 1. What happened to the graph? It's just the same graph but moved to the left. That's positive 1. It moved to the left. If we move it 2, it will move 2 units to the left. Pag negative 1 naman, it moved 1 unit to the right. So ang effect lang ng A, this A here, is the translation of the graph. So suppose dito, x plus 1, what is the domain if the function is x plus 1? What is the domain?
Greater or equal to negative 1.
Yes, x that are real numbers but they have to be greater than or equal to. So equal siya, we are not excluding negative 1, kasama pa rin siya, negative 1. And the range, how about the range? Ano yung range natin? Ano yung kasama?
0.
0 lang.
Greater than or equal to 0.
Yes. So, wala namang nagbago sa range kasi magmula dyan, paakyat ang kasama sa range. Yan. So, ang inaapektuhan lang ni A dito ay ang ating domain. So, pag negative 1 naman, adi magiging positive 1 lang ito. Positive 1. The range is just the same. Ating radical functions. So for the trigonometric functions, let's use an applet para mas madali. I will be posting this one in our Google Classroom after our lecture. So when we say trigonometric functions, the first thing that should enter in our brain, in our mind, is of course the three basic or main trigonometric functions. We have the sine function, the cosine function, and the tangent function. SIN, that's the shortcut for the sine function. COS, cos, we read that as cosine, and then TAN, tangent function. So let us investigate the graph of the different functions, trigonometric functions, so that we'll be able to tell the domain and the range then of these functions. Although, naka-cheat na tayo, no? Nilagay ko na dito, actually, yung mga range and domain dito. So if we click the function that we want to evaluate, the range, the domain, and the period actually will appear here. So let's start with the sine function. This is the mother function, the most basic sine function that we have. And there are a lot of elements. And by the way, before we proceed to the elements of trigonometric functions, yung x natin, ano yung mga ito? The input that we put, that we use in our trigonometric functions, they are not just numbers but are angles. That's why in your module, we started with an angle, the definition of an angle in standard position, and all. So we will not be discussing those ones because it's already discussed in our module. So we will simply present the different elements now. F of x equal to sine x. X here is an angle, and by the way, we normally use angles in radians and not in degrees. Although, of course, it doesn't really change our answer. Pi is the same as 180 degrees. 2 pi is the same as 360 degrees. When we look at the mother function, y is equal to sine x. Ang value ng a dyan is 1. So it's set as 1, and the value of b is again 1. And the value of a, what does it tell again? If I make it greater, so from 1, if I make it say 2, what happened to the graph? If I make a equal to a higher number 3, alright, lalaki yung amplitude. So amplitude is just the height of the graph, but it actually does not change the graph. So the graph still passes through the origin, and it's just the same. It's this curve, except that it changes the height of that graph. From 1, now what if we make it say 0.8? Yan, mas liliit pa yung kanyang amplitude. So that is the effect of A. That's why we name it A, to denote amplitude. How about B? Ano yung effect ng B? If we make it higher, if we increase B, it will compress the graph. But the graph still crosses the origin. So ganun pa rin yung itsura. If we make it lower, say 0.2, ayan, hindi na natin makita yung buong cycle, no? Kasi masyadong na-expand. So if we make it higher, it compresses the graph. If we make it lower than 1 but greater than 0, it expands horizontally. How about if it's negative? Baliktad lang siya. Downwards, papuntang sa taas. From this one, nasa mataas tayo, papuntang. So yun lang naman. How about if A is negative? So ganun din yung effect pag negative at positive yung A natin. That's negative. So from the origin, down, papuntang taas. Pero pag positive, from a higher position, it goes down. Now, anong ibig sabihin ng period? Period is just a measure of one cycle. Ano bang itsura ng one cycle sa sine graph? Ang isang cycle, yung parang ito, what object can we use as an analogy siguro of this one? Parang S yan. From the origin, parang may isang mountain dyan, another inverted mountain that comprises one cycle. And kung ano man yung angle kung saan siya tumigil, that will tell us the period. So that is the period. It comprises one cycle of the sine function because the trigonometric functions here are cyclic. Anong ibig sabihin ng cyclic? Paulit-ulit lang yung graph. This is one cycle and starts another cycle. So parehas lang sila, magkakamukha lahat ng mga cycle. So actually, when we graph trigonometric functions, we do not have to write the other cycles. One cycle is enough. Anyway, we know that it is a trigonometric function and ang itsura niya ay ganun din sa mga susunod na cycle. So that is M, that's the period, and the formula is 2 pi over B. So ang nakaka-affect kay period ay si B kasi siya ang nagko-compress nga at nag-i-expand kay function. So if it's 3, 2 pi over 3. So saan galing yung 3 na period dito? From B. So 2 pi is a constant. That is always the numerator. So we cannot actually see ang 2 pi over 3 dito pero somewhere here, nandito. If you can see my cursor, doon sa may x-axis, dapat nandyan kasi ito yung isang cycle natin. And that angle is 2 pi over 3. That's period. Alright? Now, what is C and D? C and D here are the vertical and horizontal shifts. Translation lang siya. So what does it do? It transfers the graph horizontally. So if I put it a positive number, high positive number, for example 3.4, pumupunta sa left yung graph. Pag sa negative naman, pumupunta yung graph sa ang D, vertical translation yan, vertical shift. So it moves the graph upward and downward. So if D is 2, ang graph natin nag-move siya 2 units above. If it's negative 2, ang graph natin nag-move siya 2 units below. Let's put this one to 0 again. Now, how about the cosine function? Let's talk about the cosine function. It looks the same with the sine function, kaya lang yung period natin, yung itsura ng isang cycle ay magkaiba. So parang V ang itsura. So we start here. If we trace the curve, pababa, pababa. So parang V ang itsura niya. Ibalik natin ito sa 1 siguro para makita natin yung mother function muna. So that is the most basic cosine function that we have. Q of x equal to cosine x. So if we again increase the value of a, it will change the amplitude. So it's just the same with the sine function. Yeah. So the sine function, one cycle of a sine function starts from here. Ang cosine by pala, cosine not sine. Yung sine kanina nag-start sa origin. So the cosine function, if C and D are 0, the cosine function starts not at the origin. Pag nag-start siya ng origin, that's a sine, that is a sine function. So yun actually yung pinakamabilis na paraan para malaman kung sine or cosine yan. And the shape of one cycle nga, parang V siya na letter. D still tells the period. So if we make it 2, 3, sabi natin 3. So our cosine function here is 1.2 because that's the value of a cosine 3x. So makikita natin yung range dito. What is the range? Well, obviously, everything is covered by the graph doon sa x-axis. So the domain is R. By the way, another way of writing this one is just the same concept. Pwede natin gamitin yung interval notation. We call this one as the interval notation. So it extends to the negative infinity to the positive infinity, meaning every real number. So all real numbers. For the range, by the way, hindi natin pinakita kanina no yung side. Balikan natin. For the range ng cosine function, you notice so how are the values changing? Is it affected by the amplitude? Yes. So if I increase this one, nag-change siya. So y is, the range is this one. Y is less than or equal to 1.8 but greater than or equal to negative 1.8. So it's based from the amplitude. If we look at the graph, ganun talaga. Kasi ang range ay ito lang. Yung yellow na ito, na part, yan. Yung nakuha dyan na part ng y-axis, that's just the range. So hindi ka magkakaroon ng y value na sa taas na niyan. So that is actually affected by the amplitude. Kasi height nga yan. So we can write our range like this para hindi na mahirap. Less than or equal to the positive value of the amplitude and then negative value of the amplitude. If I make it 2.6, ganun din lang. The range is the set of all y such that y is less than or equal to 2.6 but greater than or equal to negative 2.6. So ganun yung pagbasa ng ganyan, ng inequality na tatlo. We start with the middle one, y is equal to less than or equal to 2.6 but greater than or equal to negative 2.6. Hindi yung negative 2.6 less than or equal to y less than or equal to 2.6. It doesn't mean anything. So parehas lang yung dalawa. Ito yung mas kompleto. Y element of R. Balikan natin yung sign, hindi natin pinakita. Ganun din lang naman. The domain is always the real number. So any angle can actually be used as an input. Any number in our x-axis. That's what we mean by R. And then the range is affected by the amplitude. So A is 3.1. So the range of this is all set of y less than or equal to 3.1 but greater than or equal to negative 3.1. Of course, y is an element of R. Let's now talk about the tangent function. Zoom natin yung konti para makita natin. Medyo iba yung itsura ng tangent function from the other two functions. The formula for the period of a tangent function is pi over b, not 2 pi over b. That's why the period is 1.5 in this case because b is 3. So pi over 3 is 1.05. So yung red dito, they are still asymptotes. So the graph will never touch those asymptotes but it gets closer and closer. The domain, medyo maliit siya. Anyway, I will be posting this one in our Google Classroom. Ito na yung formula. For the domain of any tangent function, set of all x element of R such that x is not equal to, this is the formula, pi, positive or negative pi over 4.17. What is 4.17? If we go back, saan natin nakuha ang 4.17? So the domain is not affected actually by A, but by B. If B is 2, eksakto natin ang 2. Then the domain is the set of all x, but x cannot be equal to plus or minus, what is pi over pi? That's 1. So 1 minus 0. 0 naman to k. The range is always the set of real numbers. If we make b equal to 3, this is the domain. So nakabigay na sa applet yung ating domain. Ito kasi, yung nandito na 0, mag-iiba yan kung magkakaroon ng value ang c. Pero normally sa examples natin, that's always 0. Ayan, so yun lang. That's all about our different trigonometric functions, the sine function, the cosine function, and the tangent functions. Sige, tapusin natin yung last. We will end with the other type of function, type of transcendental function. We have our, ito, lahat yan. Exponential function, logarithmic function, and there are special types of logarithmic functions. So, ipakita natin agad ngayon ang itsura ng exponential function. So, ito yung definition ng exponential function natin. So, ang base natin dito ay 4, tapos ang kanyang exponent ay x. That's the variable. So, a raised to x, that's the general form of our exponential function. So, of course, I can change the value of a. So, pwedeng gawin kong 4.5 raised to x. That is already an example of an exponential function. If I make it 6.1, ganun din. Can it be 1? Ganyan. Parang 1 raised to x. If you notice the graph, it does not already looks like an exponential function. It's just a line. Hindi yan pwedeng maging exponential function. So, actually, a cannot be equal to 1. Yun lang yung restriction natin. So, a is any number greater than 0, because if it's exactly 0, ganyan na naman yung magiging itsura ng graph, yung graph ng function natin, which does not resemble an exponential function. So, a can be any number. So, pwedeng 0.1 yan, 0.2, 0.3. Hindi rin pwedeng maging 1. Pwede siya maging 1.1, 1.2, 1.3, and so on. So, ang bawal dito, negative numbers, 0, bawal din yan, bawal din yung 1. The domain as shown in the graph is the set of all real numbers. Lagay natin dun sa 2. Ganyan. So of course, the graph here sa right part is extending indefinitely, so it will cover all numbers in the positive x-axis. Dun sa kabila naman, obviously, it is an asymptote. The x-axis itself is an asymptote. And of course, the graph will cover everything here at the left part. Kaya real numbers ang ating domain. Yung range, obviously, hindi lahat ng values sa y-axis natin. So, ang kasama lang ay yung mga positive real numbers. 0 is not even included here as the range. Because again, at exactly x equal to 0, the graph is only approaching. So, asymptote yung nansan. Yun lang ang meron sa exponential function. What if merong isang form, that's the basic, no? That's the mother function. What if we add ganyan? So, parang instead of just 2 raised to x, our function now is 2 raised to x plus a constant 1.4 in this case. Gawin nating eksakto 2. So x plus 2 raised to x plus 2. Ganon pa rin. Walang nagbago. Kahit yung itsura ng graph, ganyan. Pag less than ang a, pag less than 1 yan, mag-iiba lang konti yung direction. The domain is still the real numbers, set of real numbers, and the range is the positive real numbers. Move on to the logarithmic functions. Iba na naman yung itsura niya. Andito sa part ang kaniyang graph. The most basic is ito, log y equals log x. Tapos yung base niya ay a. So, in our case, dahil pinili natin na a is 1.6, makikita natin dito ang 1.6. So, this is the general form. This is the current logarithmic function that we have based from the values of a. Value of a. Ayan. So, pinapalitan ko lang yung base. You look at how the graph also changes. Pagbabaan ko, yan. Pwede bang exactly 0 yan? Hindi pwede. Magiging line lang na naman yung ating graph. If you notice, yung domain and range natin, nagkabaliktad lang from the domain and range of the exponential function. Domain is the positive real numbers. Bakit? As we can see in the graph, this is only the part of the x-axis covered by the graph. 0 is not even included. Kaya positive real numbers lang yan. 0 is not positive. The range, if we look at it, at this graph, so may part na magka-cover sa negative numbers, may part na magka-cover sa positive numbers. So, papunta doon. This is the mother logarithmic functions or the basic logarithmic functions. What if we add another element, b? Saan natin i-add yung b na yan? Dito, sa x. So, x plus 0.2. Galing sa b yung 0.02. Yung 2.1 ay galing sa a. Still our base. So, by the way, di ba? Base ang tawag natin siya. The relationship of the exponential function and logarithmic functions are explained in your module. Okay, so let's have an example of this one. So what if exactly 2 ang b, tapos a is, sabi natin 1.2. So our logarithmic function is log x plus 2 to the base 1.2. Ano ang kanyang domain? Well, medyo mahaba na siya kasi depende, no? How do we read this one? Set of all x such that x is greater than negative 2. So, ang effect kasi ni b ay tinatranslate din niya, tinatransfer niya yung ating graph. So, if I make it positive to the right side, so maging 6.1, parang na-move to the left yung ating graph. Kaya negative 6.4. So, it's just the same number, negative nga lang because it's moving to the left. If we make it positive naman, negative, b is negative 6.9, makikita natin na positive 6.9 greater than or greater than lang. Greater than 6.9, x element of r. For the range, it remains r. So, r pa rin na yan, naman yan. Now, we have a special logarithmic function. We call them common logarithmic functions. Why are they called common logarithmic functions? Because their base is set to 10. So, naka-fix na 10 yung kaniyang base. So, syempre, walang effect yung a kasi nga nakaset yan. Yun yung ibig sabihin ng common logarithmic function. And of course, the domain is the positive real numbers. The range is still the set of all real numbers. So, anong silbi ng b dito? It still translates the common logarithmic functions. So, mag-iiba yung ating domain. Ito yung pinag-uusapan natin. Apart from the common logarithmic function na base 10, meron din tayong tinatawag na natural logarithm. Ang na-fix naman dito ay yung base natin pa rin. Instead of 10, it's the Euler's number, si e. So, this is just the same as log x base e. Ang shortcut niya ay ln x. So, bale, parehas ito, log x, tapos ang base natin ay e. Another way of writing, in the more common way of writing, this is ln x. So, parehas lang yung ibig sabihin doon. This is a logarithmic function na nakafix na e ang kaniyang base. Pag 10, we call that common logarithm. So basically, the same lang yung information natin dito. The domain and the range is just the same with the common logarithm. With the mother function, the basic function. So pare-parehas lahat yan. Kapag naglagay tayo ng b, mag-iiba yung domain syempre kasi nga ita-transfer niya yung ating graph.